Solve 4 to the power 2x minus 1 is equal to 64. So I'm going to see if I can change 64 to the base 4. Yes, I can. 64 would be 4 cubed. So 4 to the power 2x minus 1 is equal to 4 cubed. When the bases are same, we simply work with the powers. So 2x minus 1 is equal to 3. So the bases are no more in the picture. So 2x is equal to 4, adding 1 both sides, dividing by 2, x is equal to 2. Solve 8 to the power x plus 3 is equal to 16 to the power x minus 1. There's no way I can change 8 to 16 power something or 16 to 8 power something. The only way I can work this out is changing 8 to 2 cube and changing 16 to 2 power 4 and go back and put the powers. X plus 3 equal to x minus 1. I'm going to go ahead and distribute the 3. So this becomes 2 to the power 3x plus 9 is equal to 2 to the power 4x minus 4. When the bases are same, I simply work with the powers, which is going to be 3x plus 9 is equal to 4x minus 1. I add 1 on both sides and subtract 3x on both sides. So I simply get, oh, so this is 4. I'm supposed to distribute it 4, I'm sorry. This is a 4. So it's going to be x is equal to 13. Solve 10 power x is equal to 3.9. Taking common log on both sides, I'm going to take log of 10 power x is equal to log of 3.91. So x is a power, comes right up in the front. Log 10 is equal to log 3.91. So x is equal to simply log of 3.91. Solve 7 to the power x plus 2 is equal to 410. You can either take ln or you can either take log. I'm going to use log here. Log 7x plus 2 is equal to log 410. 7x plus 2 is the power, so it comes right up in the front. So x plus 2 log 7 is equal to log 410. I'm trying to solve for x, so x plus 2 is equal to log 410 over log 7. Let me go ahead and solve that. So x plus 2 is equal to 3.09. Subtracting 2 from both sides, I get x is equal to 1.09. Solve log x plus 5 base 4 is equal to 3. So I'm solving logs. The easiest way to solve a log is to change it into exponential. So I'm simply going to draw my arrow from the base to the other side. So now x plus 5 now becomes 4 cubed. That means x plus 5 is 64. Subtract 5 from both sides. X is equal to 59. Solve log x base 5 plus log 4x minus 1 base 5 is equal to 1. Before I go ahead and solve, I'm going to make sure I have a single log. I'm going to combine this. So addition of logs now becomes multiplication. So this becomes x times 4x minus 1 base 5 is equal to 1. Now I have a single log. I'm going to go ahead and change it into exponential. Draw my arrow from the base to the other side. So this is x times 4x minus 1 is 5 power 1. So 4x squared minus x is equal to 5. Bringing everything over to one side, I get 4x squared minus x minus 5 is equal to 0. So I'm going to go ahead and factor this one. So the factors would be 4x minus 5 and x plus 1 is equal to 0. So I have x is equal to 5 over 4 and x is equal to -1. And if I go ahead and plug -1, I have log of -1 base 5 plus log of 4 times -1 minus 1. And this is not possible because I cannot have a log of negative number, so x is equal to -1 is not my solution, so x is equal to 5 over 4 is my option. Solve log x plus 4 minus log 2 is equal to log 5x plus 1. The first thing I gotta do is I gotta make sure I have single log on both sides. So the subtraction of log now becomes division of log. Now once I have logs on both sides with the same basis, I simply work with the numbers. So x plus 4 over 2 is equal to 5x plus 1 over 1. It's not there, but I'm just going to put over 1 so it's easy for me to cross multiply. So I have x plus 4 is equal to 2 times 5x plus 1. So I have x plus 4 is equal to 10x plus 2. And subtract 2 on both sides and subtract x on both sides. What do I get? 9x is equal to 2. So x is equal to 2 over 9. This problem gives us the formula. A is equal to 37.3 e power 0.0095. This has to be a t. Models the population of California in millions, where t stands for years after 2010. And they're asking us, when will the California population reach 40 million? So they gave us a value, which is 40 million. Let's go and put it up in the formula. 40 million is equal to 37.3 e to the power 0.0095 times t. Whenever you're solving exponential function, make sure the exponential functions are by themselves. So I'm going to divide both sides with 37.3. What do I get? Let me go ahead. 40 divided by 37.3 gives me 1.07 equal to e to the power 0.0095 t. Now that I see the exponential is by itself and it's e to the power, so I'm going to use ln on both sides. Now if I go ahead and find ln 1.07, I would end up getting 0.0677. And this would simply be ln e is 1, so this would be 0.00095 t. To find t, I simply divide both sides with 0.0095, 0.0095. So my t value would be 0.0095. I would end up getting 7.12. And so that would be approximately in the year 2017. Remember, t is years after 2010. How long to the nearest tenth of a year will it take $8,000 to grow to $16,000 at 8% annual interest? The formula we use for annual interest is P e power RT. We have the value of A, that is 16,000, value of P, which is 8,000, value of R, which is 0.08. So I have 16,000 is equal to 8,000 e to the power 0.08 times t. And again, the exponential has to be by itself. So I divide both sides with 8,000. So I get 2 is equal to e to the power 0.08 t. Exponential is by itself, and I have a e, so I take ln on both sides. So ln2 would be 0.693, and this would simply be 0.08t. Dividing both sides with 0.08, 0.08, I would get approximately 8.7 years.